So welcome everyone. It is a pleasure to have you for the 7th RFF-CMCC-NAVIGATE webinar. The topic for today is the sources of uncertainty in long-term global scenarios of solar photovoltaic technology. It corresponds to an article that was published earlier this year in the journal Nature Climate Change by Marc, Jaxa-Rozen and Evelina from the University of Geneva. We have the pleasure to have Marc with us today to present his paper. Marc is a postdoctoral researcher at the Renewable Energy System Group, the University of Geneva, where his research focuses on uncertainty analysis for global emission scenarios as part of the Navigate Horizon 2020 project. And we also have the pleasure to welcome Sibel Eker, who is a research scholar at IIASA and a senior researcher at Climate Interactive, and she will be our discussant today. Before I give the floor to Marc, let me say a few words about Navigate project, which is co-organizing this webinar and in which the work that Marc will be presenting has been developed. Navigate is a project funded by the EU, and it aims to develop the next generation of integrated assessment models. It has three main pillars, aiming to improve the representation of systems, both production and demand, and their transformation, and the representation of the human component with social and spatial heterogeneity in the models, as well as improving the usability of modeling methods and results. And the project is implemented by a consortium of 17 partners from several European countries, as well as Brazil and China. And before we start, a few points for the webinar. So please mute your microphone and deactivate your video. And if you want to ask questions, you can write them in the chat or use the raise hand feature. So we'll have now the presentation by Marc for about 30 minutes, and then a 10-minute discussion by Sibel. And at the end, I'll moderate a question and answer session. So Marc, the floor is yours.
Yes, thank you very much, Céline, for the introduction, and thank you as well to the organizers for the opportunity to present, and to Sibel for taking the time to be here today. So let me share these slides. Is this properly showing up? Great. So this is also indeed on behalf of my co-author and supervisor, Evelina at the University of Geneva. And as Céline mentioned, so this is essentially presenting a study that we published a few months ago as part of the Navigate project. And so essentially here, like the starting point for the study was that, you know, if you kind of like look back at the last 10 years, you know, I mean, it's been a really dynamic decade, let's say, for solar PV, of course, and as well for renewables in general. And I mean, that's been kind of reflected also in just like how dynamic and diverse the scenario literature has been about PV and again about renewables in general. The point is, you know, when you take something like PV or other technologies, let's say, that can scale up quite quickly, well, I mean, we often end up with so much variation across the scenarios that were published, that, you know, it can be kind of difficult to like interpret those results, you know, from a point of view of scenario users, decision makers, and the other actors who really look at these kind of projections. And so in the case of PV, of course, well, we know there is a huge technical potential globally. So, you know, in terms of exajoules per year, there's quite a lot of uncertainty, of course. But these estimations for potential are above, for example, the range of total primary energy demand that's expected for 2050 by the different IPCC mitigation pathways. Okay, but then when it comes to like translating that potential into actual projected pathways for the use of PV, there is just this huge amount of uncertainty in the literature. And so if you look at the projections for PV generation by 2050 that were essentially published in the last decade, so those scenarios basically span 2 orders of magnitude. Okay, and so that means from less generation than we actually have now from PV in 2020, all the way to almost covering or even exceeding, the global demand of energy. So, the question for us here was to kind of try to better understand maybe, where is that uncertainty coming from, and to understand maybe how that can relate to, let's say, different technical or perhaps organizational factors. Because, for example, I mean, if you look here at this figure, so this is this ensemble of published projections for PV in the last decade that we compiled in this study, and that I'll explain a bit later. I mean, one kind of possible lens we can use to like decompose this ensemble of scenarios is to group the scenarios by the type of organization that published them, let's say. And so then, well, we can see, okay, perhaps can we find some sort of consistent relationships between maybe the type of organization that published the scenario and what kind of futures that they foresee for the adoption of PV. In the same way, I mean, look, we know that the IPCC mitigation scenarios have found quite broad audiences in, in decision-making and policy and different types of audiences. And so we wanted to see like how these scenarios compare to, the rest of the literature that we can find more broad. So, in terms of the approach and the method, so kind of the starting point again was looking at the literature of the last decade in relation to these global PV projections, which meant we included the gray literature, so these different energy outlooks, corporate and otherwise, so from actors like the International Energy Association and other different, corporate outlooks. We also, of course, included the academic literature, and then the last 2 IPCC databases, which means the 5th assessment report and the special report on 1.5 degree pathways. So for now, we kind of excluded the pathways from the 6th assessment report that are starting to be compiled because these are not quite accessible yet. So in total, we ended up with close to 200 scenarios from the academic and gray literatures, which kind of cover a pretty broad range of different types of publications and also different modeling methods. And then so we had close to also 1,400 scenarios from the IPCC, which in that case are almost all coming from process-based integrated assessment models of the type that that are dealt with in the context of the NAVIGATE project. So again, here we are focusing on global outcomes in publications that came out since 2010. And we're also limiting the projection horizon to scenarios that look at the period between 2030 and 2050. Okay, so that's a kind of choice, which means we're not looking at short-term industry forecasts, these kind of like really short-term projections, and we are also not looking at really long-term projections for the end of a century, because in that case, that would pretty much limit us to the IEM scenarios and kind of make the ensemble of scenarios a bit less diverse. So then to kind of try and describe these scenarios, so we classified them using a set of different categorical indicators, essentially. So first of all, we had a group of what we called meta indicators, which is basically just meaning like who published the scenario and when it came out. Then we also had indicators to describe the model that's kind of, let's say like underlying the projection, so like, is it, let's say an optimization or simulation model? Is it maybe just a simple analytical projection? Or, how does it deal with technical change? All these kind of like different model features and characteristics. And in the end, we also had essentially what we called policy indicators to describe what kind of, let's say, climate or technology policy might be depicted in the scenario, which means, is it, for example, a 1.5 degree scenario? Is it perhaps some sort of baseline scenario, and so on? Also, do we have explicit renewable policies? And these kind of issues. So in that case, this is information that we got directly from the publications, and sometimes like also from the underlying like model documentation and so on. But the thing is, we also wanted to maybe try extending that with information that was not quite so explicit in the publication. And so that means we used a couple of statistical methods to get the sort of additional context for the scenarios. So on top, we used this approach for text mining, essentially, to try to highlight dominant perspectives in the publications. Okay, which means, for example, is a publication maybe emphasizing fossil fuels? Is it maybe really discussing carbon capture and storage prominently, and so on? So again, to try to understand where a certain publication might be coming from, how it approaches PV. And then we also used clustering on additional dimensions of the scenarios. Okay, and these are dimensions that are other than PV specifically, but we wanted to look at the different patterns of energy use and emissions, that are included in the scenario. So that kind of, the idea was to try to understand, like, all right, is this maybe like a, is this pathway for PV coming from like a, really high energy use scenario in general, or maybe is it a high electrification type of scenario, and so on. And so that let us identify a couple of what we call scenario archetypes. And so in the end, the idea is that we try to link these different scenario indicators with the projected global PV capacity in each of the scenarios by using, in this case, a nonlinear classifier. So the idea was to see basically like, okay, knowing the basic properties of a scenario, could we sort of, predict what kind of outcomes it might foresee in the case of PV? And so then we also wanted to know, well, in that case, which would be the most influential of these indicators towards, again, the projected outcomes for PV. So yeah, maybe before we get to that part, I just wanted to kind of, illustrate a bit the scenarios that we gathered, and a couple of indicators. And so first of all, like, we can just look here at the IPCC and non-IPCC projections over time. So here this is showing generation on the left and capacity on the right on equivalent axes, related using a standard capacity factor. And so on the right panel, well, we can see that so these very highest values for PV, they tend to be outside of the IPCC projections, which is also reflected in the average capacity shown here on the left. And of course, in a way, like that's not a fair comparison. Obviously, I mean, for the IPCC, we have things like the different baseline scenarios and so on that don't include mitigation. So this is a kind of starting point to disaggregate these scenarios a bit. Also, in terms of like visualizing the scenarios, what we found to be interesting was, to maybe dive a bit more into like some of these numbers underneath, like the global like headline, PV capacity figures, because we actually found some pretty significant differences in how these different global pathways play out in terms of regional outcomes. And so here we wanted to look actually at the outcomes in Asia and the Middle East with Africa on the right. So that uses this, standard regional decomposition that breaks down these 5 macro regions, I think originally coming from IIASA. And we especially focused on these 2 regions because, well, they have both a quite high level of like unrealized potential for PV, and also a pretty broad set of, let's say, projected pathways in terms of, socioeconomic development and technology adoption. So here, basically, like this is plotting, so each marker is one individual scenario. And the y-axis is this scaled metric here for what we call like this regional PV share indicator, okay, which basically takes the regional share of global PV capacity divided by the regional share of a global primary energy demand. So to some extent, it lets us account for, different regional pathways for the total use of energy and to kind of correct for that a bit. And so then on the x-axis, so this is showing and kind of, maybe introducing the basic measure that we used for most of the analysis, which is the equivalent compound annual growth rate, or CAGR, of a global PV capacity in each of the scenarios. So in each case, we basically always sort of compute the equivalent CAGR of PV capacity from the end date of a scenario relative to a historical baseline for 2010, to kind of have this like uniform starting point to compare the scenarios. And so, putting that together here, so, if you look first at the IPCC scenarios in this case, I mean, what's interesting is that, the IPCC scenarios, they have this pretty broad range of regional outcomes, okay? And so, well, typically what this means, so being above this line here means that we have a relatively high level of kind of relative PV adoption in Asia, and relatively lower a bit in the Middle East and Africa. But we do still see like these optimistic pathways for PV growth in Africa, and some more pessimistic pathways in Asia, relatively speaking, you know. And I mean, you know, for example, here again, like these sort of outliers, that means we have a relatively high level of PV adoption globally, you know, on the x-axis. And then in Middle East and Africa, that's really kind of also like really showing a strong level of local adoption, okay? Because what's interesting is that we compare with the non-IPCC scenarios. And in that case, and unfortunately, we did not have too many scenarios that kind of reported the regional outcomes. But it's kind of interesting that overall, like the scenarios from international organizations in black, which includes organizations like the IEA and so on. So overall, they are a bit more optimistic about PV in Asia, with actually the sort of trend here, which means that the more PV is developed globally, the more actually that's especially happening in Asia, okay, relatively speaking again. But then in Africa, so okay, without reading too much into the scatter plot, but still we do see somewhat of a kind of a negative trend happening here, you know, or at least we see fewer of these pathways that would see more PV deployment in the Middle East and Africa, okay. And, you know, without going too much into the details, you know, it's basically because those scenarios don't really consider, for example, these sort of like desert tech sort of large-scale projects in the Middle East. We're also pretty conservative often about the prospects for decentralized PV at the household level in Africa, for example. So that's kind of an overview of the results, but, you know, if you kind of start to dig a bit deeper, let's say, and associate these with the different scenario features. So if you look first here at what we called, again, these meta indicators. So again, who published the scenario and when it was published. So then these box plots show the distribution of the CAGR within each kind of group of scenarios, okay? So first of all, if you look at, you know, the scenarios after grouping them by the different organization types. So first of all, actually what we can see is that the scenarios from research institutes and universities, well, they tend to have the lowest CAGR on average, okay? But they also do have the widest range, all right? So we have some pretty significant outliers on the high end, and then also on the bottom end, which typically in this case, this was some of the baseline IPCC scenarios. And by the way, what we tried to do sort of consistently here was to associate the scenarios with either the organization with which the first author was mostly associated, in the case of scientific articles, or otherwise with the institutions that's mostly associated with developing the model, you know, in the case of the IPCC databases. Because of course, I mean, that's a line that's kind of difficult to draw between research institutes and universities, obviously. But we didn't see too many significant differences there, actually. And so really the key difference that we saw was between, again, on one hand, these kind of like more research-based scenarios and the corporate scenarios here in these last three box plots, okay? And so in that case, on average, they tended to be more optimistic about PV, but they were also grouped in a narrow range of projections, okay? So not considering as much uncertainty on either side. And so then, I mean, you know, if you look at the publication date, actually, so we do see a pretty consistent pattern with, you know, as you might expect, you know, the more recent scenarios tend to be more optimistic as well about PV, which is, you know, probably to some extent a consequence of the cost assumptions being revised downwards in models, you know, as a kind of reaction to just this crazy development of actual PV costs in the last 10 years. And just this overall kind of reaction, I guess, to, you know, how much PV has been outpacing previous expectations in the last decade. And so then, like, if we also look in a bit more detail at what we call the model indicators. So most of the scenarios in the ensemble are coming from optimization models. But then, again, the most significant difference we found was between, on one hand, either optimization or simulation models, on one hand, and then on the other hand, these simpler analytical projections, okay, which might be based on, for example, a vast diffusion curve or some other type of, like, you know, for example, extrapolation of historical trends, you know, without a kind of underlying more complex model. And so these kind of simpler projections tended to be more optimistic on average about PV, although we did see some, you know, quite optimistic optimization models as well. In the same way on the bottom, well, if you look this time at what we called model boundaries. So, well, again, the most optimistic scenarios tended to come from models that either only look at the energy system only, or solar technology only, rather than global IEMs, which take this kind of more comprehensive view, of course, of the different constraints that might be affecting the development of it is interesting to note, though, that if we also split the IPCC and non-IPCC scenarios on these indicators, then the latter are still kind of more optimistic in each of the categories. All right, on the right, so for example, optimization models and energy system models here, well, they tend to be higher here for non-IPCC scenarios than the counterparts in the IPCC databases. All right, and so it would be the same pattern if we looked at publication date, in this case, that we looked at in the paper, which means that the non-IPCC scenarios that were published in the first half of the decade, let's say, well, they were more optimistic on average than the publications that were compiled in the IPCC. If we use the publication year of the kind of original scenario reference. Then, in terms of model features, actually, so if we go back to the original and complete scenario ensemble, so we actually didn't see too many differences in terms of the structural model features, like the type of foresight or the type of modeling of technological change within scenarios. Except, again, we did have this distinction between the more complex models, which kind of account for these features, and then the more simple or possibly ad hoc scenarios, that don't explicitly account for technical change and the evolution of costs, for example. So these are these kind of like unspecified scenarios happening here. We still do see like some of the higher adoption scenarios happening in the case of models with exogenous technical change, and of course at that point, well, then it depends about really the detailed assumptions that are fed to the models. And it's actually I can also mention, like, there was this quite interesting paper by Marc and colleagues that came out in June this spring. And that kind of like took a deeper dive into like some of these specific assumptions that went into these models and scenarios, with maybe more of a kind of like normative perspective on the modeling of PV in global scenarios, and some interesting insights for the future. Right? And then in the case of our own analysis here, well, I can just conclude with these two indicators that accounted for the kind of policy actually that's depicted in each scenario. So here that means on the left, first aggregating by the type of climate policy, which means, as you might expect, actually scenarios that are consistent with a 2-degree scenario, 2-degree pathway or lower. Well, they also had the highest projected adoption of PV, but still not as high as the scenarios which did not include explicit policy assumptions. Okay. And in the same way, well, if you look on the right at the technology policy or maybe the technology portfolio, so the scenarios with explicit policies for renewables, they tended to have the highest PV adoption out of the scenarios that did report these kind of assumptions. So I mean, that's not really rocket science. It's quite obvious that we could expect that kind of dynamic. But what's interesting is also, there was this average difference between scenarios which had a full technology portfolio without limitations, while then scenarios with a restricted technology portfolio, which in the case of the IPCC scenarios often means, for example, scenarios that limit bioenergy and BECCS. So in that case, these scenarios did have slightly higher adoption of PV, which means they might emphasize renewables a bit more, in the absence of BECCS, for example. All right, so those are like some of the indicators that we gathered, again, directly from the scenario publications and so on. But we also wanted to understand a bit better, like what perspective these scenarios came from. Okay, so the idea was to try to account for, a couple of the other key dimensions of the scenarios other than PV. And so here we used clustering to kind of identify like a sort of basic future, that the scenario projected in terms of, the development of energy demand, the development of the share of electricity within that, and also the growth of CO2 emissions. Okay, and so, after clustering on these 3 dimensions, we ended up with these 4 main groups of scenarios, okay, that are shown here on the right using parallel coordinates. Which means, for example, this group here that has high energy use and low CO2 emissions. It has high energy use and high CO2 emissions, rather. So yeah, so here it kind of gives us this this reference scenario from the SSP databases, which would be like one of the SSP type of scenarios. While we had this other type of scenarios, which were more emphasizing like high electrification within the scenarios, combined with low CO2 emissions. Okay, which in this case would be more like this sort of SSP1 type of projection. And so then when we kind of try to relate, the PV adoption numbers to the kind of cluster membership of the different scenarios, well, as you might expect, I'll show on the left, using again these kind of box plots. So we had, for example, the high electrification scenario here on the top left. Well, it also had the highest projected use of PV within the scenarios. While the high energy and high CO2 type of cluster, so again, these sort of like baseline scenarios or like SSP5 type of scenarios, again, nothing too surprising, but these tend to have, the lowest average adoption pathways for PV. And one thing, yeah, we didn't really have time to look at that in detail, but it could have been interesting also to kind of look in detail, like within each of these groups of scenarios to see, for example, if the PV adoption might have maybe a different relationship with, model and scenario features across these different clusters of scenarios. Okay. And finally, we also had some, I thought interesting results with the topic modeling. So again, this was like statistically identifying dominant text perspectives in the summaries of the publications by using this latent Dirichlet allocation kind of method. And so we found that the most optimistic projections tended to be associated with renewables, in really the kind of textual presentation of the scenarios here. So you can see like some of the main keywords here of this text perspective. So it does include a bit of an economic component as well. We had actually quite a few of the corporate scenarios that were included there. Well, for example, in the case of carbon capture and storage here, these publications tended to be more conservative on PV growth, as we might expect. And so that kind of gave us this like additional indicator to, disaggregate the literature a bit more and to, again, maybe get some insights into what kind of perspectives these publications approach PV. So putting all that together, well, we wanted to see in a more quantitative way what were the most influential of these indicators towards the PV projections. Okay, and in this case, so we couldn't really do like a classic regression analysis here because the sample was this kind of messy like sample of or ensemble of opportunity, let's say. So we couldn't like really cover all combinations of organization types and model types, for example. We were limited by what was in the literature. So to still get some insights into the general pattern, so we basically grouped the PV scenarios into 5 quintiles of projected PV capacity growth, okay, which means the lowest, most conservative 20% scenarios and so on. And so then we used the XGBoost algorithm to try to match the scenario indicators with their projected outcomes for PV. And so we actually found that we could sort of predict with something like 70% accuracy, actually, which quintile each scenario would fall into by only kind of using these generic indicators, which did not include things like, the explicit cost assumptions, for example, that might be used in a scenario. Of course, these are not independent of the more generic indicators, but still we kind of wanted to know, like, all right, only knowing these basic features, what could we tell about really these future PV outcomes? And so if you then look at where this uncertainty was coming from, well, overall, the most influential variables actually seem to be the policy assumptions on climate mitigation and also the scenario archetype, which was this kind of overall like energy future that's depicted in this scenario. But what was interesting is also to kind of break this down again into the IPCC and non-IPCC types of scenarios. And so then in that case, actually, we could see that in the non-IPCC scenarios on the right, which kind of covered like a bigger range of different organization types and also different modeling methods. And so in that case, actually, well, oops, sorry. Yeah, so it's really these two indicators that stand out, so again, model boundaries and also organization types, okay? And so it means, we could say like, if we know who published the scenario, so like what kind of organization, if we know when it was published, which is this date indicator in green here, and if we know how it was modeled in terms of a general modeling type, well, we can get a pretty good sense of expectations towards future PV growth. Or at least, and this is a kind of important, of course, assumption, is that this is always in relation to the PV literature. So it's always relative to what's out there in the literature. So in the end, I think overall, like, if you maybe like take a bit of a step back, here and look at the literature on global prospects for PV, I think like one of the things that really defines this literature is just how much uncertainty there was about the prospects for PV. And again, this is because like I think this is a technology that has quite different technically plausible pathways that it could follow in the next couple of decades. So I think it could maybe be interesting also to kind of take this perspective on the literature for other technologies that have these kind of attributes, so that can be scaled quite quickly and that have a large potential. So, I mean, there was this paper by Charlie Wilson and others in Science that discussed, granular technologies, which again can be kind of scaled up quite quickly at a decentralized level, which means, electric mobility, heat pumps, and so on. And so I think the scenario literature could also be interesting to analyze, in relation to these kind of technologies. Overall, I think like one of the other takeaways was that, overall, we did see lower outcomes for PV in the IPCC scenarios on average, and also in terms of the very highest pathways. And well, that's again kind of dependent also on the fact that, these are scenarios that, are mostly from the first half of the decade, because the ensemble was quite dominated by the AR5 scenarios. But we still thought it was important to highlight, because these are scenarios that, they have found quite a broad audience, again, in decision-making and policy. That's often an audience that's not quite so familiar with some of the assumptions that go into these scenarios, and also with the way this literature has evolved in the last decade. And I mean, I thought it was interesting, just a kind of anecdote that we had during this literature review is that, if you look at the ExxonMobil energy outlook from last year, so again, the outlook that came out in 2019, well, as you can maybe expect from them, they had quite conservative projections for the future of renewables and PV specifically. And they actually referred to the EMF27 scenario exercise to kind of like, compare their scenarios and say, well, look at these numbers, we're kind of in line with the IPCC and so on. And so, they kind of left it at that. But of course, if you're familiar with the IPCC literature, that the EMF27 scenarios by now, I mean, they're more than a decade old. Almost, of course, and we know that these assumptions have been revised quite a lot since then, and so it's important to account for that when we interpret these scenarios. But in the end, intentionally or not, these are scenarios that can be kind of taken out of their context pretty easily and framed in ways that are not what was originally intended. Okay, so the idea of this kind of review was to maybe give a bit of more perspective, to kind of make these scenarios easier to interpret, again, for a broader audience. Because, the IPCC, that's one thing. But then on the other hand, well, the corporate scenarios, okay, on average, they are more optimistic, but they do tend to be in a pretty narrow range, compared to the academic literature, okay. And it was also interesting to see that the IPCC did explore a bigger range of different regional pathways, so again, being more optimistic about PV in Africa, for example, than the IEA, for example. And so I think in the end, again, like if you want to have a full picture about the uncertainty that's out there in the PV scenarios, I think it helps if you kind of, keep in mind that, well, it's helpful to just seek out that sort of diversity and, the different organization types and modeling methods, producing different scenarios. And again, just keeping in mind these sort of, who, how, and when type of questions to put the scenarios in context. So I think on that note, well, I'll leave it at that, and I'll be happy to move on with the discussion. Thank you.
So thank you very much, Marc. Sibel, if you want now to share with us your thoughts about the paper.
Sure. I will also share my screen and show a few slides as I discuss this. So thank you very much, first of all, Céline, and thanks, Marc, for your clear presentation and this very important work, of course. Let me start with what I wanted to say at the end, because I think this work Marc presented is a great contribution methodologically to make sense of growing scenario ensembles, to navigate growing scenario ensembles, That's why I titled my my presentation with this title, and that's, I think, the main point that I would like to make today. However, before getting there, there are 3 points I would like to highlight about this study. The first is the relevance of solar PV uncertainty, like practical concerns about this. The second one is the is a reflection on this study in terms of dealing with uncertainty, types of uncertainty in scenario studies. And lastly, as I said before, I would like to elaborate on the importance of this approach for navigating scenario ensembles. Marc already mentioned the decline in the cost of renewables in general, and particularly solar PV. I wanted to remind this is a historical view on the marginal cost of solar energy and wind energy. We see this expected learning curve and almost exponential decline in the last 30 years. And IRENA, I think, reported that in the last decade, between 2010 and 2019, solar PV experienced the largest reduction in cost. That was like 82%, if I remember correctly. And in the next 2 decades, solar PV is expected to show the highest increase in the generation capacity and energy supply. So, and the stories from last year's World Energy Outlook and IRENA reports related this growth mostly to the reduction in the cost. So we start with this cost reduction in mind. So this basically could be the reason for the uncertainty we are experiencing. And Marc already told us that this may not be the main reason. But I wanted to look at the relevance of this and what this uncertainty means in the future solar PV generation capacity. So the left graph here is what Marc already showed you. This is the solar PV generation supply of primary energy demand only in IPCC scenarios. And I wanted to run a quick and dirty exercise to see what this solar capacity means for the global anthropogenic emissions. So if I plug in this scenario ensemble of solar PV supply to a model of energy system, without any technological change, policy change, etc., just plugging in the solar PV capacity and look at the resulting emissions, that results in a range of emission reduction as much as 6 gigaton per year by 2050. And this is like almost 10% of the expected emissions by then. So it is quite a significant amount for the net zero pathways. So the point I'm making here is that I think this study about the uncertainty of solar PV is not only a scientific exercise to understand scenario databases better, it also has practical concerns to understand the role of solar PV, especially, and different energy technologies in the energy transition and mitigation pathways. And the second point is about how this study deals with uncertainty. This framework this is a commonly used framework for classifying and communicating uncertainty in model-based policy analysis. I think it's a good synthesis, but of course not the framework or not the way that the things have to be done. But I find this quite comprehensive and useful. It looks at 3 main dimensions of uncertainty in model-based studies. The first is the level of uncertainty, the other is the nature of uncertainty, and lastly, the location of uncertainty, where in the modeling and scenario generation process, uncertainties arise or inserted by the analysts. So I think Marc and Evelina's study, even though it didn't follow this framework, of course it didn't have to, it covered most of these dimensions of uncertainty because the the uncertainties they take into account, they call it indicators like meta indicators, model indicators, and policy indicators. They cover quite a big portion of this uncertainty framework. For example, they look at the system boundaries considered in the modeling studies, they look at the conceptual model, and they look at the meta indicators like organization type, which actually refers to ambiguity and nature of uncertainty. So I think that was quite comprehensive in terms of the uncertainties they considered. And in terms of the contribution of this study, methodological contribution to navigate scenario ensembles, Marc already represented their approach, which combines different techniques very well, in my opinion, because it doesn't look only at quantitative or numeric indicators of scenarios. It also has a text perspective. It also looks at the archetypes. So it tries to retrieve utmost information from the available scenarios in that sense with this multi-method approach. And we know that there is a growing need or calls in the scientific community to have a wider set of scenarios. I think that there are many studies, but here I just copied two I know very well. The last one was a call to improve the SSP-RCP scenario framework. And they call for a more diverse set of scenarios, including more uncertainty. That means that scenario ensembles will grow and grow. And in addition to that, in addition to this need for bigger scenario ensembles, we also have the tools to access these scenario ensembles and to analyze them. This one is, for example, is a Python package published by colleagues in the integrated assessment modeling community to access the IIM and IIPCC scenario databases and to analyze them. So it's like we have the need to have more scenarios and analyze them. We have the tools to access these scenario databases. And so when these two things exist, the question is, how are we going to do that? How are we going to find the relevant research questions and get useful information from these scenario ensembles? And I think Marc's study answers this question because it presents a very useful approach, transferable useful approach to make sense of scenario ensembles and to get useful information from scenario ensembles. That's why I think it's the most important contribution, especially given that scenario ensembles will grow and grow. There is one caveat in my opinion though, and I stated this clearly earlier. However, I think this is due to the maybe practices of modelers or scenario producers. So Marc already presented us how the projected PV cost was in the scenarios he analyzed. And he also mentioned how many scenarios he included. So this study includes in total around 1,500 scenarios. A big fraction of this is from IPCC, but only 116 of them have explicit cost data, capacity cost of solar PV, and an even smaller portion, like 38 scenarios, have explicit information about the marginal cost of levelized cost of electricity produced by solar PV. So I think this is quite important, because if we are to say that at the end, it's not the techno-economic assumptions about solar PV that determine the scenarios of projection capacity. If it is the organizational aspects or other things, we need to have more data, more information from the scenarios about the techno-economic assumptions, so that we can compare and see if this is indeed the case. However, if this information is not available, there is not much analysts can do. So I think here I would like to repeat my call for more transparency and documentation. And of course, there is huge amount of work done in the IIM community in recent years for more transparency and documentation. But given that these are past studies, past scenarios, I think it reveals the lack of it and creates limitations. And that's all what I wanted to say. If Marc wants to reflect on this last point, I will be more than happy to hear what he thinks. And yeah, thank you very much.
Yeah, thank you very much, Sibel, for a very nice description and discussion. And yes, indeed, that it was really interesting how you mentioned, indeed, like when you look at PIAM and the other kind of initiatives that have been kind of really developed to kind of help modelers increase the let's say the transparency and the documentation of these models. Without being a modeler myself, like I'm not involved in these efforts myself, but I feel like that's something that can really play a huge role in making it easier to kind of communicate these kind of assumptions. Because indeed, like now when you kind of look at some of the older scenario databases, you know, the kind of structured databases, you know, you kind of see like, okay, the SR 1.5 database at least included, as you mentioned, like some of the cost assumptions. But then the RFF database was really quite tricky to work with, because often, for instance, we had to we didn't even include many of these scenarios from the RFF because they did not at that point disaggregate non-biomass renewables, for example. They only reported one single value for wind and solar. And so it does seem like there's been this sort of move towards like greater detail in how these scenarios are reported and compiled, and I think that's going to be really helpful to support this kind of analysis in the future for possibly other types of technologies, you know, which actually some colleagues in one of the Navigate tasks are also taking forward and try to kind of apply these kind of perspectives on other technologies. Because indeed, for example, when it comes to like these specific techno-economic assumptions, so for example, in the case of our analysis, we kind of conveniently, because indeed we couldn't really specifically look at the impact of costs for each and every scenario, and only for a small portion of them. So we wanted to see like, okay, with a sort of like minimum available set of indicators, could we still get a sense of what's happening in the scenarios? And indeed, what actually happened is that for the scenarios that did report cost assumptions, you did see a fairly high correlation between, for example, well, as you might expect, first of all, a correlation between the date of publication of the scenarios and what kind of costs they're projected. And then you also saw a correlation between the type of organization and the type of model, and what kind of costs. Of course, because of a limited sample size, it was kind of difficult to like really conclude about that, but I thought it was interesting to kind of figure out that, okay, again, knowing like the type of organization, you could get a sense of, all right, what kind of costs are published in the literature, you know. Obviously, it's biased by the fact that only certain scenario developers are reporting these variables. But it's, yeah, so the more transparency we can have about these kind of assumptions, the easier it's going to be to kind of, yeah, interpret that.
Okay, thank you very much for your presentations and the discussion already. So for the participants, if you have some questions, don't hesitate to write in the question and answer at the bottom of your screen, or to use the raise hand function if you want to ask yourself. At the moment, we have like one comment and one question from Robbie Morrison. So the comment is to mention an initiative, the Open Energy Modeling Initiative, and saying that it might be of interest, and I don't know if one of you, Sibel or Marc, know about it and want to react. And then the question is precisely whether you checked if the use of open source model and data was a factor changing results or not.
Yeah, that's a very interesting question, actually, about the role of possibly open source models. I would say, at first, I remember like we tried to see if we could kind of, yeah, let's say highlight some of the open source models. But the issue is that, first of all, in the IPCC databases, there is a very limited number of scenarios that come from open source models, which is perhaps an issue in itself, but that's perhaps a different story. And the point is, we didn't really want to, sort of single out specific models and so on. But it could be interesting to look systematically at what's been published and see if, for instance, perhaps open source models, perhaps there's a link somehow between how quickly assumptions can be revised in open source models relative to sort of more closed off models and scenarios, and perhaps in turn that would then have an influence on what kind of outcomes are foreseen. But that's not something I've looked at. And Sibel, I'm not sure if perhaps that was part of your other kinds of research, but it could be interesting to look at that specifically indeed.
I agree. It would be interesting, especially if there will be more and more open source models in future. But in the current state, it's rather limited, like you already mentioned.
Well, actually, I think there is this big trend to go for more and more open source, and some of the big models that underlie the scenarios that are in IPCC database are becoming open source. So I think the trend is coming up, and that might actually change some elements, and it will be important and interesting to look at that in the future. So we have another question from Franco Boscolo, asking whether policymakers know about these studies. And maybe actually I would myself add and broaden a bit that question and ask you for what you would take as lessons for scenario users and policymakers from your study.
Yeah, I mean, my personal perspective, again, just kind of seeing this spectrum of uncertainty that's out there, is that, look, it's not about, we don't know which models are going to be right, we don't know which ones are going to be wrong, of course, and so the way to get a sense of that, I think, is, again, just that notion of diversity in different organization types and perspectives can be helpful. I mean, it's interesting, you've had these other retrospective studies looking at, for example, energy futures in the UK or in the US as a function of scenarios published by different types of organizations. Often, for example, you saw scenarios from NGOs, people like Greenpeace, or in the US, the Rocky Mountain Institute, for instance, that managed to see some trends coming ahead of some other types of organizations. That doesn't mean they're going to be right in the case of PV or other renewables, but at least including these kind of more diverse type of organizations systematically, I think can be helpful when you interpret the scenarios. If there's a balance to be found, when we talk about communicating these scenarios to decision makers, there is a balance to be found between the diversity of perspectives and just the sheer number of scenarios that we can kind of meaningfully communicate. We kind of have to be careful about that. And I do think that's where these kind of increasingly like the tools Sibel mentions, like some of the quantitative methods to assemble and maybe single out specifically diverse scenarios that can really capture the uncertainty in a limited number of scenarios. I think there's a lot of potential still in developing these kind of approaches and really testing them out in practice with policymakers and decision makers. So I think that's something that could be quite interesting to explore in the context, not necessarily of PV perhaps, but perhaps also some of the other technologies.
When I first read about this study, though, about Marc's and Evelina's study, my reaction was that policymakers would be shocked by these results because so the most important factors, Marc's conclusion is that the most important factors is not the more scientific things that we put into the models and scenarios like techno-economic assumptions, methodology, but it's climate policy, okay, that might be expected, but also the organization who, when, and how develop these scenarios. So if you tell this to a policymaker, it might be quite shocking because it's not the science that is put into the models that is supposed to be very, very objective, but it is these subjective factors like the organization who develop these scenarios and when they develop this. I think a policymaker could be shocked by this. However, this is also about the perspective, and we need to change our perspectives and have a little paradigm shift there maybe, because it means that we expect this objective positivist science, and we might be tending to exclude uncertainty and wider set of scenarios. So in my opinion, there is nothing wrong with this wide uncertainty range and different organizations making different assumptions leading to different scenarios. It's just that we need to know why they are in that case, and this study, Marc's study, helps us to do that, to know why they are in that way, and they make decisions better in that way. So I think it's a bit controversial to say that it's not the more scientific aspects, but who, when, how develop these scenarios. But this is not a big concern in my opinion, because it requires a perspective change in uncertainty and scenario analysis.
Okay, thank you very much. Do you have other questions or points you would like to raise from the participants? Yes. So from Daniel D. Hoop, possibly outside of the subject, but still important, when forecasting the growth of variable renewable like PV and wind and related growth of operators present on the market, can't we avoid the price war during midday hours by embedding the variable renewable inside or outside operators of hydro plants? For example, this should avoid negative prices to occur. I'm not sure your study really looked into that, but maybe because you're working on PV more generally, you would have some comment about that question.
Yeah, I would actually say I think that's a kind of issue that indeed, so we didn't look at these kind of issues explicitly, because we kind of kept it at a pretty high like aggregate level in terms of how we look at the models. But these are exactly the kind of issues actually that if you're interested in more research in these directions. So the paper by Marta Victoria and colleagues that came out in June, there indeed, like some of the analysis they did really indicated that, for example, you know, when you have models which have especially higher spatial resolution, higher time resolution, and these are all trends that the integrated assessment models, amongst others, are moving towards in the case of VREs. When you also have a more kind of explicit representation of sector coupling beyond electricity. And these are the kind of issues that become kind of easier to include and represent in the models. And which actually what they concluded is that, yeah, the higher resolution we have spatially and temporally in the models. And so the more of these kind of issues that are raised by the commenter, the more they are included in the models, the higher the share of PV actually in the energy system. So I think they kind of showed a pretty systematic trend towards that and kind of discussed ways forward. So I think, yeah, that's kind of, that's for sure a relevant issue for future developments.
Okay, thank you very much. I think we're coming to the close of the seminar. Thank you very much, Marc and Sibel, for your presentation and the excellent discussions. Thank you to the participants for your questions, and of course also thank you to CMCC for the organization of the webinar. I think it will be made available in Navigate website as well as on CMCC YouTube channel. So if you want to find it, it will be there. So that's it. Thank you very much and have a good rest of the day.